All right, in this video I'll be finishing our discussion on how to solve rational equations, and we're on number 11. We have x minus 12 over x is equal to 1, and there's only one denominator here. That makes it pretty easy to find the LCD. It's just going to be x, and we'll multiply each of our terms by x, basically multiplying both sides of the equation by x to clear the fractions. X times x is x squared. We have x times 12 over x. The x's will cancel. You're left with minus 12. And on the other side, you're going to have 1x or just x. Now, this is a quadratic equation, and so we're going to want to get 0 on one side. And so that means we're going to want to subtract x on both sides. And so we're going to get x squared minus x minus 12 is equal to 0. Notice it's important to write the left side in descending order. You've got the x squared term, then the x to the first power, and then the constant. So you want to have it in that correct order. And so now this is a trinomial. We'll be able to factor this hopefully using the AC method. We need two numbers that multiply to negative 12 and add to our b term, negative 1. And 3 and 4 are going to work. You can see if we got to make one of these numbers negative, so we get negative 12 when we multiply. And since we want to add to negative 1, we need to make the 4 negative. So notice 3 plus negative 4, that's going to give us the negative 1. So that's the combination that works here. And notice this is a 1x squared, so we can use the shortcut I've talked about. We can just write this or factor this as x plus 3 times x minus 4 equals 0. And if you set each of these factors equal to 0, you're going to get x equals negative 3 and x equals 4. And by the way, you know what, I did forget, x cannot be 0 here because that would certainly cause our denominator to be 0 and we'd be undefined. But neither of our solutions were 0, so they're both good solutions. All right, let's move on to number 12. We've got 7 over x plus 1 is equal to 5 over x minus 3. Now, so basically we have a fraction equal to a fraction here. We've actually already found the LCD for these two denominators. We just multiply them together. We get x plus 1 times x minus 3, both within parentheses. And so we're going to multiply both sides of the equation by our LCD. Oh yeah, and I should mention that our restricted values here are going to be negative 1 and 3. Notice if x were negative 1 here, we'd get 0 in the denominator. If x were 3 here, we would have a problem. And so these are the two restricted values. So let's go ahead and multiply both sides by our LCD. Notice on the left, the x plus 1s are going to cancel, and we're left with 7 times x minus 3. On the right, the x minus 3s are going to cancel, and we're left with 5 times x plus 1. And so on the left, we're going to distribute. We've cleared the fractions, so now we've got some simplifying to do. So 7 times x will get 7x. And 7 times the minus 3 is minus 21. On the right side, we'll have 5 times x, or 5x, plus 5 times 1, which is 5. Now, notice we do have x on both sides of the equation, so I need to isolate x on one side. I'm going to go ahead and subtract 5x on both sides. And so on the left, we have 7x minus 5x, which is 2x. And let's bring down the minus 21. On the other side, we're just going to be left with 5. So we have the two-step equation 2x minus 21 equals 5. We'll add 21 to both sides. We'll get 2x is equal to 26. And then divide both sides by 2. Or you can just do that in your head. You're going to get x is equal to 13. So notice our restricted values were negative 1 and 3. And so this is a good solution. All right, let's move on to the last slide, but these are problems that are going to take a little bit of work. But you know what, actually, let's go back to what we just did, and I want to show you something here. I'm going to erase a little bit, clean things up here. You may recall when you have a fraction equal to a fraction, this is called a proportion. And in fact, going from here to here, really, notice we can cross multiply. You may recall, it turns out when you have a proportion, the cross products are equal. So 7 times x minus 3 is going to equal 5 times x plus 1. And so if you prefer, you could just cross multiply and you get that first step out of the way just by doing that cross multiplication. So that's another way to approach these problems. It only works when you have a proportion, fraction equal to fraction. So otherwise you're going to have to, do the way that we did it the first time. All right, so let's go to 13 now. So I'm going to go ahead and find the cross products here and set them equal. I can multiply 2x times x plus 1. And before I do that, I should list our restricted values. Notice x can't be -7. You can see that here. And x can't be -1. That would be a problem on the right. And so let's cross multiply now. We have 2x times x plus 1. And that's going to equal 5 times x plus 7. So again, we'll distribute. We'll get 2x times x is 2x squared. Plus 1, so 2x times a positive 1, we'll get a plus 2x. On the other side, we're going to get 5x plus 35. And you can see what we have here is a quadratic equation. So I'm going to want to get 0 on one side. Normally what I like to do is keep my x squared term. If it's positive, I want to leave that one alone. And so we're going to get rid of the terms on the right. We'll need to subtract 5x on both sides. And we'll also need to subtract 35 on both sides. So on the left, we're going to get 2x squared minus 3x minus 35. And then on the right, that's just going to be equal to 0. So notice we have a trinomial. It's a quadratic equation. And so the only technique we really have to factor this is, actually, hold on just a second. Actually, let me correct myself. We actually have several ways to solve this quadratic equation, but the first thing we want to try is factoring. There's a good chance we can use the AC method, so let's give that a shot. And if that didn't work, we would want to use the quadratic formula. So we're looking for two numbers. Notice my AC here is -70, so two numbers that multiply to -70 and add to our b term, which is -3. And hopefully you can do that one in your head. When I think of 70, I think of 7 and 10. And notice those numbers are going to work. They're going to have opposite signs so that they multiply to a -70. And since they add to a negative, I want to make the bigger number negative. So the 10 will be negative. And so we get 7 plus -10 does give us -3. And so let's go ahead and split our b term. Just bring down the 2x squared. Minus 3x becomes 7x minus 10x. And don't forget to bring down your 35, your minus 35. And let's factor by grouping here. We can factor out an x in the first two terms. We get x times the quantity 2x plus 7. So when we factor the next two terms, we're expecting a 2x plus 7 factor. And notice to get that -10x, I'm going to have to multiply 2x by a -5. So we get, and notice -5 times 7 does give you the -35. So let's see, we have two terms with a common factor of 2x plus 7. We're going to get 2x plus 7 times x minus 5. Remember, you can always cancel these out or cross those out to see the x minus 5. Now we can see that x equals 5 is a solution. And to find the other one, we want to set 2x plus 7 equal to 0. We'll subtract 7 on both sides, divide by 2, and we get -7/2. So our two answers are -7/2 and 5. Notice neither of those are a restricted value, and so those are good answers. So I would encourage you to maybe try the next one. Actually, maybe we'll do that one together, and then maybe you could try the last two. let's go ahead and, first of all, we've already found the LCM for these denominators, or the LCD, but what we're going to want to do before we do anything else is let's factor those denominators. You have 3x plus 6, which you can factor as 3 times x plus 2. You're going to always want to factor everything that you can first in the denominators, because it's going to help you to see what factors you have, whether they're algebraic factors or numerical. X squared minus 4 we can factor as x minus 2 times x plus 2. And so you can see our LCD, well, there's only one numerical factor. It'll have the 3 in it. And then also you have x minus 2 and x plus 2, which would indicate that x can't be 2 or negative 2. Those are restricted values. So our LCD is 3 times x minus 2 times x plus 2. So it's going to be a little tight here. I didn't leave a lot of space. We're going to go ahead and multiply each of the terms by our LCD. You'll notice in the first, when we multiply times the first fraction here, 1 over 3x plus 6, or 3 times x plus 2, the 3 and the x plus 2's are going to cancel, and you're going to be left with 1 times x minus 2, which is just x minus 2. I don't really need the parentheses here, but I did put them in there. And then in the next multiplication, the x minus 2 and the x plus 2's are going to cancel, and you're just left with 3 times 1, or plus 3 here. On the other side, the x minus 2's are going to cancel, and you're left with 3 times 3 times the quantity x plus 2, or 9 times the quantity x plus 2. So let's simplify the two sides. On the left, you don't really need the parentheses there, so we have x minus 2 plus 3. On the right, I distributed, and you get 9x plus 18. So let's simplify the left side. We still have negative 2 and 3, which combine to give you 1. So we have x plus 1 is equal to 9x plus 18. We've simplified everything that we could, and notice we do have x on both sides, so we need to isolate x on one side. I'm going to go ahead and subtract 9x on both sides. So we'll get x minus 9x, that's negative 8x plus 1. On the other side, you're going to get 18. So we'll subtract 1 on both sides next. We get negative 8x is 17. And then divide by negative 8, so x is negative 17 over 8, which is not one of our restricted values, and so that's a good answer. All right, so now I would encourage you to try 15 and 16 and then watch the video. All right, so on 15, first thing I would do is factor the n squared minus 4. And by the way, this is not one that we found the LCD before. But you can see we have 3 algebraic factors here, n minus 2, and n plus 2. There's no other factors, algebraic factors, in the denominator. And so we'll multiply those together to get our LCD. N times n minus 2 times n plus 2. Now keep in mind that means our restricted values are 0, 2, and negative 2. So let's multiply each of these fractions, or each term, by our LCD. Notice with the first product here, the n plus 2's will cancel, and we're left with 3 times n minus 2, or 3n times the quantity n minus 2. And then when we multiply by 2 over n, notice only the n's are going to cancel. And in fact, remember, n minus 2 times n plus 2 is n squared minus 4. I'm just going to go ahead and write this as plus 2 times n squared minus 4, because the easiest way to go from here is I'm going to want to distribute next. On the right side, the n minus 2's and n plus 2's cancel, and you're left with n times 4n minus 4. So you can see I still have a lot of simplifying to do now that I've cleared fractions. I've got to distribute 3n times n minus 2. I'll get 3n squared minus 6n. I've got to distribute 2 times n squared minus 4. I'll get 2n squared minus 8. On the other side, we got to distribute n times 4n minus 4. We'll get 4n squared minus 4n. So still a lot of cleanup to do here. 3n squared and a 2n squared on the left side is going to give me 5n squared. And then I have minus 6n minus 8. On the right, we still have 4n squared minus 4n. So we need to pause for just a second here, and you hopefully can see that this is quadratic. So with quadratic equations, we want to get 0 on one side, everything else on the other. And so let's subtract 4n squared on both sides and add 4n to both sides. 5n squared minus 4n squared, we're going to get n squared. Negative 6n and a plus 4n, we'll get minus 2n. We'll bring down our minus 8. And of course, on the right side, we're going to have 0. So this is our quadratic equation. Looks like we might be able to factor this one using the AC method. We need two numbers that multiply to negative 8 and add to negative 2. So 2 times 4 are the ones that are going to work. And notice the 4 needs to be negative so that when you add to a negative 4, you do get negative 2. So we're going to get n plus 2 times n minus 4 is equal to 0. So if you set each of those equal to 0 and solve for n, you get n as negative 2 and 4. But notice negative 2 is one of our restricted values, so we're going to throw that one out. And so 4 is the only good solution here. All right, last one. So we've got denominators of x minus 3, x plus 3, and x squared minus 9. Notice x squared minus 9 is a difference of squares, and in fact it factors as our other two denominators, x minus 3 times x plus 3. So our LCD is just going to be those two factors, x minus 3 times x plus 3 multiplied. And so we're going to multiply each term in the equation by the LCD there. And notice our restricted values here will be 3 and negative 3. So let's go ahead and multiply each term by x minus 3 times x plus 3. So when we multiply by 3x over x minus 3, the x minus 3's cancel, and you're left with 3x times the quantity x plus 3. And then we have minus 9 over x plus 3. The x plus 3's are going to cancel here. And we're left with a minus 9 times the quantity x minus 3. I'll distribute in the next step. On the right side, x minus 3 and x plus 3 both cancel out, and so you're left with just 54. So when we distribute here on the left, we're going to have 3x squared plus 9x. We'll distribute the minus 9, we'll get minus 9x plus 27. It's equal to 54. That's interesting. So the 9x and the minus 9x is 0. We're going to have 3x squared plus 27 equals 54. And here's where we need to pause for just a second again. This is a quadratic equation, and I could certainly try getting 0 on one side, but one of the things we learned when we were solving equations, I should say quadratic equations where there was no x term, is normally we're going to want to use the square root method to solve those, which means in this case we want to get x squared all by itself equal to a number. And so we actually don't want to get 0 on one side here like we normally would. I'm going to go ahead and subtract 27 on both sides. We get 3x squared equals 27. Then divide by 3, and we get x squared equals 9. And we know if we take the square root of both sides, plus or minus on the right, we're going to get x equals plus or minus 3, which means there's two answers, 3 and negative 3. Notice those are restricted values. That's why I have an answer here of no solution. All right, and that's the end of this video.